All right, so this one, can we do equal bases? No, because we have more than two terms, okay? Equal bases only works when you can say, you know, b to the x equals b to the y. We can't do that here because we have the 1. If we didn't have the 1, if it were equal to 0, we could totally, well, and the 6, we could totally do equal bases. So we have more than two terms. So now, can we rewrite as a log? No, because again, we have more than two terms. We can't combine these because it's over subtraction, so that there's no help there. Can we log both sides? No, again, because of that pesky 1. If it was equal to 0, sure, we could take the log on both sides. Can we do substitution? Yes. And that's the way we're going to go here, okay? And so we're going to say, you know what, I see a pattern here. I'm going to let's u be e to the x, okay? And this is a very common thing to do, this change of variable. If you go on into trig, you're going to do it in trig. You're going to do it in calculus a lot. Okay, so when I do this substitution, I've got e to the x, so that's going to be u, right? Minus 6. Now, e to the negative x is the same as 1 over e to the x. So I could say this is 6 over u, or 6 times 1 over u. Let's put it that way. Equals to 1. And so this is really a rational function. So we can get a common denominator, right, of u. So I got u squared minus 6 over u equals 1. We can cross multiply, and we don't have to worry about, you know, if u might be equal to 0, because e to the x is never going to be equal to 0. So I've got u squared minus 6 equals u. And hey, look, that's a quadratic, right? And you can solve that either by factoring or a quadratic formula, right? There's no need to complete the square because we can factor here. So this one, I'm going to just go right on back up here. We've got u minus 3, u plus 2 equals 0. So we know then that either u equals 3, well, as is right now, we have two solutions, u equals 3 and u equals negative 2. Of course, we're not done yet. We've got to go back and undo our substitution. So what we've got is 3 equals e to the x, and negative 2 equals e to the x. Now, e to the x, that graph, looks like this, right? So it never goes negative, so this is a junk solution. That's an extraneous solution. So we need to discard that. But 3 equals e to the x, that one we can solve. We're going to solve that by rewriting as a log, ln of 3 equals x. And there we go. We have our answer. So it wasn't too painful, but we can go and graph this one. Let's see here. Go to GeoGebra, turn this stuff off. All right, so we are going to say, hey, I got y equals e to the x. And we could just do e, right? To the x minus 6e to the negative x. All right, so that's going to look like that crazy function there. And we want to see when that is equal to 1. So where do those two functions intersect? And so we can do our intersection tool. And wait, it didn't do that. And so we've got 1.0986. Sorry, I didn't think it had pulled out the right thing. But what is ln of 3? It is 1.0986. So we found our answer correctly. Okay. Now, this is a good place to break before we move, and we're going to move on into logarithmic equations.